So how do we deal with data in MATLAB? So hopefully you've downloaded the waterlevel.mat file from Isidore, and then you need to put that in a specific location for us to be able to access it. So if you've downloaded it and it's on your desktop or on your downloads folder or something like that, please move it to your MATLAB folder or wherever on your computer that you're kind of normally writing and saving MATLAB programs, because we're going to have that in that location to be able to use it. So I'm going to change my directory also. So what you want is to be able to see that waterlevel.mat file over in the left-hand side in your current folder, like with your other files that you have, your other M files you've written for class, or however you have your file organization system lined up. So take a minute and make sure we have that. Uh-oh, did I leave my... Oh, well, this will be fun. I left my lecture notes in my office, so we're going to go on the fly here. So we have, in this file, we have some water level data. We've collected some water level from Lake Powell on the Arizona and Utah border, and we've got water level of Lake Powell in each month from the years 2000 to 2007. We have water level in feet. That's what's in the file. So what this file has in it is it's just a big matrix of numbers. There are, so we have this big matrix. We have 12 rows. One for each month of the year. And we have 8 columns. One for each year that we have. So the data is from the year 2000 to the year 2007. So the data in the first column is for year 2000. The data in the last column is for year 2007. And then we have data for all the years in between. In the months, in our first row, we have January. And in our last row, we have the data for December. So we have this big matrix of data. If we were to open it up and look at it, which we will in a second, it's all data with a lot of decimal places in it. It's not going to be easy to type in whatever, how many ever numbers, 96 numbers of data. Did I do my math right there? 12 times 8. Is that 96? Yeah. So it's not easy for us to type in 96 pieces of data into MATLAB. I'm not mean. I wouldn't ask you to do that by hand. So how can we get that data into MATLAB? That's what we're going to try to learn today. So not only how do we get data into MATLAB, but how do we save and kind of export data in MATLAB? And it's a really helpful skill, I think, for people outside this class to kind of deal with data, because that's what you're going to be dealing with a lot of times, you know, in your job, in other classes, that kind of thing. So what is this data, what is this MAT file? So a MAT file is a specific type of file that is kind of designed by MATLAB. It's MATLAB data, that's why it's MAT. So it's got data in it. And if we bring that into MATLAB, you'll see that it's just kind of a matrix of data. So how do we get that into MATLAB? There's a bunch of different ways that we can do it. I'm going to teach you guys just a few of them and then kind of point you in the right direction to find how to do this for all sorts of other types of data, because there's tons and tons of different types of data, and we're not going to go through all of that in this class. So the easiest way to import data into MATLAB is to use the data import wizard. It requires no actual coding. You just have to use this import data nice button up here at the top of MATLAB. So if we hit the import data button, you'll get a pop-up file or pop-up box It'll ask you to find whatever file it is that you want to import. If it's in your current working directory, like it should be kind of the only file or one of the only files that's located there. If you have text files or other things, those might be in there as well. But if we click on water level, what's going to come up is this nice box. It says it found water level. It said it looked like it was a matrix. It has 12, it's 12 by 8, so 12 rows, 8 columns. That's exactly what I told you we would have in it. And if we click finish here, you'll see that now over here in the bottom left, we have a variable called water level, and it has 12 rows, 8 columns. If we open it up, double click on it and open it up in the variable window, you'll see that we have, all this data of the water levels in 12 rows, 8 columns, exactly like I told you. So rather than having to type all these numbers out by hand, which would be really horrible process, we can get that data into MATLAB really, really easily. You can do the same thing with Excel spreadsheets. They work just the same in the data import tool. The visual representation of it looks a little bit different, and I'll show you guys exactly how that works, because I think that's kind of the most common thing that you'll deal with probably outside of this class is kind of bringing in data from Excel spreadsheets or text files, but we'll talk about those. So first off, we have our data now in MATLAB. That was really nice. That was really easy to use the data import tool. But what does that mean? Because we didn't write any code, we'd have to go and do that every single time we wanted that data. So every single time I wanted to bring my water level data in there, I have to go to the import wizard, I have to click next and and bring that data in. I probably, would get annoyed by doing that if I had to open hundreds or thousands of data files. So we might as well learn how to code it, because that'll be a little bit easier. So once we decide we want to do that, how do we do these commands in MATLAB? So let's clear out our workspace so that we get rid of that water level data, and I'll show you what the command is in MATLAB to bring that data in without having to use the data import tool. So there's a really simple command. It's just called load. So we type LOAD, you open your parentheses, and then inside of your load command, you can provide MATLAB a lot of information. If it's a mat file, if it's one of these nice files that MATLAB has made itself and then is specifically designed for MATLAB, all we have to tell the load command is the name of that file, and we have to put it in single quotes, just like when we create our diary files. So we say water level and then .mat for the extension, close our single quotes, close our parentheses, press enter, and ta-da, just like with the data importer, we have that data down there in our workspace now. So if it's a mat file that is created by MATLAB, you can use that load command, and that's by far the easiest way to do it. Questions?
Ours didn't work.
Okay, did you get an error, or did you just not?
It says error using load.
Okay, let me come look. It just might, I'm guessing that the file is not in the right direction.
I know it isn't, I just don't know how to do it there, because I changed the settings on my MATLAB thing, so like,
Where's your file on your computer? Where's your MATLAB? Download it first. We have to know where it is. So probably with your desktop. On your desktop. Well, we don't want to, so we don't want to click on there. We can actually like figure out where it is. So take your, take that copy that file.
I'm just saying. It could happen.
Now go back to the
thinks we need to work on
Anybody else having problems with their data loading?
that one.
Need help?
Would work without.
When it wonders.
So once we have this data into MATLAB, so we can do our load command, we can do it in the command window, we can do it in a script, we can do it in a function. Wherever we need that data, we probably want to put this load command so that it's loaded, it's in our workspace. It's just basically the same thing as saying, water level is equal to all this data that we'd have to type out. You're just going to replace that with this load command, and that's going to create a matrix that has all of that data in it. So what do we want to do with this data? So if we go back to our problem statement, we said we want to write a script to complete the following tasks. We want to load the data, so we did that task. The second task is to calculate the information below. And so we want to use, and I also said to use the appropriate built-in MATLAB function to do that. So we're going to calculate 3 different things. So first we're going to calculate the average, what did I say? Average water level in the lake for each year. So average for each year. The average for each month. And the average over the entire 8-year period. So the first question is, what is the built-in MATLAB function that we should be using here? How do we calculate average? Mean, right? So we need to use the mean function, but we need to figure out, can we use the mean function to give us these 3 different things? We're going to calculate 3 different averages. What do we get out of the mean function? So let's go back and kind of figure out what we get from the mean function. So where do we go to find information about the mean function? I want to know something about a function in MATLAB. Help, or search documentation, or Google, right? So let's look in the help documentation. We click mean. We go to the help documentation, and MATLAB tells us, it calculates the average. Okay, I knew that. That's not that helpful, MATLAB. What is it trying to do? So it tells me here in the center, if I give the mean function a vector, then mean returns the mean of all the elements, right? So if I give MATLAB 10 numbers in a vector, it's going to give me the average of all those 10 numbers. It doesn't matter if the vector is a row vector or a column vector, it's going to give me the average of all the numbers that I've given it, right? And it says if A is a matrix, then mean A returns a row vector containing the mean of each column. So if we give MATLAB our water level, right, we call this variable, this big matrix that we drew is our water level variable. If we give MATLAB the water level variable, we say mean water level, which average is it going to give us? The average for each year, the average for each month, or the average over the 8-year period?
For each year.
For each year? How do we know it's each year? So each column, we said, we drew our picture. This is why the picture is helpful, right? We said our columns are our years. So we know if we take the average, we're going to get the average of each column, which means the average in each year. So that one is easy, right? We just say, let's say average each year is equal to mean of water level. How many numbers do I expect is going to be in average each year? 8, right? It's going to be 8. And MATLAB tells me that that is going to be a row vector, right? So that means 1 row, 8 columns of data, 1 for each year. So if I were to draw my picture for average each year, it would look like something like that with 8 numbers in it, right? What if I want to get my average for each month? What do I want? Do I want the average of, I don't want the average of the columns, right? We did that. That was the average of each year. I want the average of what data in my matrix? Each row. John? Put a little thing, right? What is the thing called? That's apostrophe. What does that mean to MATLAB in math terms? Transpose. So that's called a transpose, not just the little thingy that everybody likes to do this. Once we've taught you how to do that in MATLAB, you just kind of like to go, oh, that thing. It's called a transpose. So what if we put our transpose in there? So if I put into MATLAB, if I said average each month, mean of my water level, and then I put my transpose after that. What does the transpose do?
Just give you the same vector, just in a column.
Right, well, yeah, so it's going to transpose my water level data, right, to MATLAB. MATLAB's going to say, it's going to think to itself, instead of having 12 rows and 8 columns, I'm flipping the dimensions, so I'm now going to have 8 rows and 12 columns, and then it's going to give me back the average of each month, because those are going to be now in the columns. How else could we do that? So there's a couple different ways. So let's go back to, not to Isidore. Let's go back to our command window and we just try some of these out. So let's do if we did average each, we'll do the average each year first. I was going to type that in. Is equal to mean of my water level. What did I expect to get? I expected to get 1 row, 8 columns. That's what I got, right? I got 1 row, and MATLAB's telling me I have columns 1 through 8 of data. If I go and I open up average each year, you'll see that I've got 1 row, 8 columns, exactly what I expected. If I do the same thing, but I do now for my columns, so average each month is mean of my water level with my transpose, what do I expect? Am I going to get 1 row, 12 columns, or 12 rows, 1 column? One row or 12 rows? 1 row. So it's going to be the same orientation, 1 row, 12 columns, because all I did was flip my input into that function. I just flipped the dimensions of the input into the function. The output is still going to be the same kind of way, 1 row, 12 columns. It's up to us. MATLAB doesn't care. MATLAB doesn't know that those are months. It's up to us to kind of know that those are months. How else could we do that? So there's a couple different ways to use the mean function. If we go back to the help documentation, if we look at the second kind of option here in MATLAB, you can tell MATLAB that you want to take the mean of something and then comma dimension, or DIM. That tells MATLAB that you want to kind of flip the mean function into a second mode rather than taking the average of each column. If you put comma 2, that tells MATLAB to take the average of each row. So it's just kind of the second way of using that function. So instead of using our transpose, so we keep our water level data just the way that it was, we just add in a comma 2, and now we flipped the mean function into kind of the second mode or the alternate mode. And what did that give us? It kind of gave us the results also transposed kind of in the opposite way. We got 12 rows and 1 column of averages back out. So those are 2 different ways of doing the same thing. It's kind of whatever clicks in your brain, whatever makes most sense to you. To me, I like the transpose way, but some people don't like the transpose or don't remember what the transpose is. So I like to teach you both how to do both of those. So questions about that? What about our third average here? We want the average over the whole 8-year period. So what does that mean, John?
Just take the mean of the average each year.
Right, so we kind of want to take the mean of the mean, right? Because if we get the mean, one of our mean functions, we're either going to get the average in each year, or we're going to get the average in each month. If we now take the average of either one of those, we should get the average over all the months in all the years, over the whole 8-year period. So we can do that a couple different ways. So we have, we'll say average 8-year is equal to mean of average each year, something like that. Or we could put our average each month there, really doesn't matter. So if we say average 8-year is equal to mean of average each year, we now get one average that's the average of all the data that we have. Do the same thing with the average each month. If we trust MATLAB math, we should get the same exact average out regardless of how we do that average. How else could we do that? If I didn't already have average each year or average each month, what could we do? Yep, Craig?
Could you like mean of the water level?
Right, so we could do mean of the water level. So it's kind of the same thing. So we did average 8-year. Instead of having one of these other intermediate averages in there, we could take a mean of the water level data. Just have to make sure we have enough parentheses in there. Press enter, same number, right? So there's a couple different ways of doing those averages. And all the MATLAB functions, kind of the built-in functions like sum or standard deviation or min or max or anything like that, they all kind of work in the same way. You can use them kind of on rows or columns depending on how you set them up or how you give them the data. Or you could take the min of some of the data, something like that. All right? Questions about that? Okay, so if we go back to our task list, if we look at our top task here on this page, I said for each month and each year. What should we be thinking about now that I've said for each month and each year? What kind of things might we need? Loops, right? What kind of loops? For loops. So we should already be thinking, I think I might need some for loops to do this problem. The question would be, how many for loops? Can we use one for loop? We said no. I heard a no over here. Why not?
Because it's like two different things.
Two different things are changing, right? In this problem, we have the month that's changing, and we have the year that's changing. And those are changing at different times, right? We have 12 months, we have 8 years. We can't use one for loop because one of them would either go through too many numbers or not enough numbers. So we have to have two for loops. We're going to have one for loop to control the month. We're going to have one for loop to control changing the year. All right? So we haven't even read the rest of that part of the task, and we already think, okay, I think I need two for loops, right? That should clue you in there. Then we say, for each month and each year, if the water level meets the conditions below, display the month and year and a message, blah, 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 blah. So let's look at the very first one there. So if the water level is greater than 50 feet above the average water level in the lake over the entire 8-year period. So if I want to test and see if the water level is greater than 50 feet above the average over the whole 8-year period, what kind of thing am I going to need to write? What kind of MATLAB code am I going to need to write there? If statement. So I'm going to need some sort of if statement, and then we also said we need the nested for loops, right? We're going to have two for loops, and we're going to have an if statement, just to answer this one part of this problem. So does that make sense to everybody? We haven't even thought about what goes into any of those things, but we kind of know the structure. So we can kind of start laying out our plan, right, to do 2 for loops and then an if statement. So I don't think we have enough time to kind of delve into that yet. We'll finish this on Wednesday. So I'm going to leave you, hanging on the edge of your seat, waiting for what do these for loops look like for Wednesday. All right? Questions before we go? Like I said, if you didn't do well on the quiz number 2, please come talk to me about any questions you have, anything you don't understand, because I think it will definitely, if you work and try to get things together, you'll do much better on quiz number 3. All right? See you guys on Wednesday.